'cause I get a good feeling.
Hi,
Yeah.
scholars. We're going to do a couple examples where it can be useful to find a common denominator. So let's take a look at this example. The number of inches of water in a bucket during a steady rain shower is given by the expression. We're just going to write it over here. 2/5 T plus 6/5. So this right here, just so we can keep track, this is referring to inches, right? The number of inches of water. So this whole expression is referring to a number of inches of water. Great. Okay, we can keep reading now, right? It's given by the expression 2/5 T. Well, so now we really need to know what is this thing T. So let's see, where T is the number of minutes since the shower started. Great. So this thing represents the number of minutes since it started. If there are 6 inches of rain, and so I'm going to put that in red as well because this whole thing represents the number of inches, right? So if there are 6 inches of rain in the bucket, how long has it been raining for? So this question is really asking us how long. This is how much time, right? This is really how much time has it been raining for. Okay, so there are 6 inches of rain in the bucket. So we can actually create an equation here equals 6. Okay, because this is the number of the whole expression represents the number of inches, and they're telling us that number of inches in the bucket is 6, right? I mean, this whole situation is basically, here's a bucket. It starts off with some water. In fact, it starts off with 6/5, right, inches of water, and then it's raining, and after some time, it gets more and more water, right? This is what this situation is modeling. Okay, so how could we use common denominators here? Now, you could sort of multiply everything by 5. That's a fine way of doing it. We're going to do that a little bit later. However, here, notice that on the left side of the equation, we have denominators of 5 and 5, and that's good for us. So on the right side of the equation, wouldn't it be nice if we could rewrite 6 as a denominator where it has a denominator of 5? Sure it would. Well, we can because 6 is really nothing more than 30 over 5. And we can double check that because 6 times 5 is 30. 30 divided by 5 is 6. 6 over 1, right? We can say that we can think about this as proportionally. So 5 is 5 times as big as 1. 30 is 5 times as big as 6. There are many, many different ways of sort of reasoning about this, but let's see what it buys us. So instead of 6, I'm going to just cross 6 out because we're going to replace it with this new fraction 30 over 5. And now look at what we have. Since we have common denominators here, here, and here, we can sort of ignore them. Right? They're not really affecting what the answer is to this problem. So we can rewrite the whole thing as 2t plus 6 equals 30, right? 2t plus 6 equals 30, right? And this right here, we can solve that equation pretty easily. This is just a 2-step equation. I'm not even going to spend time doing it. Subtract 6, 2t is 24, divide by 2, and we end up with t equals 12. And so that's our answer. How long has it been raining for? It's been raining for 12 minutes. Okay, so this is one way where we can use common denominators to get an answer, to find the answer to this question. Let's take a look at another one. If 5/9 m minus 4/18 m equals 6/7 plus 8/7, what is the value of m? So here's another case where we're going to need common denominators because our denominators now are 9, 18, and 7, right? 7 and 7. So first thing we can do, let's just look at the right side of the equation. And look, they do have a common denominator. So when they have a common denominator, we can add the numerators. 6 plus 8 is 14 over 7, right? Common denominators. And, I'll be darned, that's just 2. So look how this ugly fraction, the sum of 2 fractions, is really just another way of writing the number 2. Okay, now let's go to the left side of the equation. And I always like to draw a line to make sure I keep things on the right sides of my equations. So here I have 5/9 m minus 4/18 m, and here I have a problem because it is true that the 9 and the 18 are not common, right? They're different numbers. So this 5 is different, qualitatively different, quantitatively different than this 4, because this 5 is referring to 5, right? As we saw in earlier, right? This 5 is referring to 5 of these things that are ninths, and this 4 is referring to 4 of these things that are 18ths. So they're different, right? It's like comparing apples and oranges or feet and miles. So we need to find a common denominator here. Well, if I just look at 9 and I look at 18, and I remember all of my multiplication tables, which of course were all memorized for this point, right? We should jump out. It should jump out in the top of your, in your mind. It should pop right out that 9 times 2 is 18. So let's take this fraction, 5/9, and let's multiply it by, here, we'll do this. We'll multiply it by 2 over 2. And find out the 5/9 is really nothing more than 10/18. So now let's substitute. Instead of 5/9, we're going to just substitute this new value 10/18, and I'm just going to copy everything else. So now I have 10/18 of m, right, minus, and this is sort of slow right now the way that I'm talking through it, right? But you can imagine that if I'm looking at this problem here, I say, wait a minute, I know I need a common denominator. That's your first step. And then you say, 9, 18. I better multiply everything by 2. And then we get to 10/18 minus 4/18, and we're done, right? Like this whole step, it took a couple minutes, but really you could do this very quickly, and that's why it is really, really important. I cannot stress enough how important it is to know your multiplication tables, because if you don't see immediately 9 times 2 is 18, this is problematic. You're not going to be able to solve this type of a problem or reason in this type of a way, right? So now, anyway, let's go back here, and we have our nice common denominators of 18, and so now I can just do the numerators. So 10, right, m minus, all right, this was of course 4/18 of m, right? I just brought this down, ha ha ha. So 10/18 minus 4/18, well, 10 minus 4 is just going to be 6 of these things, 18ths of m. And we still have equals to 2, and now we're almost there. 6/18, I can say again my multiplication tables is really 1/3 of m equals 2, right? We can reason that 6/18 is the same as 1/3 in a bunch of different ways. This is a proportion, right? We're going to get into proportions, but this is just reasoning proportionally. Right? We can cross multiply and check that 18 does indeed equal 18, etc. So now we say, okay, how do we solve this? 1/3 of m equals 2. Okay. 1/3 of some number is 2. If I asked the question in that way and said, what's the number? It's 6, right? 1/3 of 6 is 2. If I had 6 apples and I take 1/3 of them, it's 2, right? Now we can do this algebraically. We know the answer now. We know that the answer right now is m equals 6. And the question is, how could we show algebraically, move from this step to this step? You could, if you want, multiply both sides of the equation by 3, right? By the reciprocal of 1/3. The 3's cancel, and you end up that m is 2 times 3, which is 6. Or when you get to this point, you could just say, what is this actually telling me, okay? What is this saying to me? So anyway, our answer is m equals 6 because 1/3 of 6 objects is in fact 2 objects.